Hello, this is 6-5, conditions of rhombuses, rectangles, and squares. There's 4 theorems in here that you need to make sure you're familiar with. The first one is theorem 6-16, and this says that if a quadrilateral is a parallelogram with perpendicular diagonals, then the quadrilateral is a rhombus. Now, that's going to be true, but this one can also this rhombus could also be a square, depending on the necessary conditions that are given to you. So it's possible that it's a rhombus and it's possible that it's a square. The next one, 6-17, if a quadrilateral is a parallelogram with a diagonal that bisects a pair of opposite angles, then the quadrilateral is a rhombus. Your next one is 6-18, and this says if a quadrilateral is a parallelogram with congruent diagonals, then the quadrilateral is a rectangle. This definition, or this theorem 6-18, is the converse of theorem 6-15 from the previous lesson. Remember that these two theorems can be stated as the biconditional. A parallelogram is a rectangle if and only if its diagonals are congruent. And the last one, theorem 6-19, if a quadrilateral is a parallelogram with perpendicular congruent diagonals, then the quadrilateral is a square. Remember that the diagonals in a rectangle are congruent and the diagonals in a rhombus are perpendicular. A square is both a rectangle and a rhombus, so the diagonals of a square will be both congruent and perpendicular. Okay, so here we're going to prove what if this quadrilateral is a rhombus, rectangle, or square based on the information that we're given. In this situation, in order to get started, you want to use the properties of the rhombuses, rectangles, and squares that we just talked about, and then their theorems that we just learned to determine whether it's a rhombus, rectangle, or square. If you are able to figure out which one of the three it is, writing the proof is going to be a lot easier. So I'm going to go ahead and just do a 2-column proof here. We know that AE is congruent to BE, to CE, and to DE. And the reason for that is that it is given. We also know that AC bisects BD, and the reason for that is by the definition of a segment bisector. Next, we can say that ABCD is a parallelogram. I'm going to draw the symbol for parallelogram. And our reason for that is theorem 6-11. Now this statement right here that I just wrote is very important because now we know that it's a parallelogram, so all of the properties of a parallelogram can be listed in our proof. So again, that one is actually very important. Once we say that it's a parallelogram, we can say that AE is equal to BE and CE and DE by the definition of congruent segments. Next, we can say that AC is, let me erase that and try that again. AC is equal to DB by the segment addition postulate. So if we were to add AE and EC it would be equal to the sum of BE and ED because they're all congruent to each other. Next, from there, we know that AC is congruent to DB, and that's by the definition of congruent segments. And lastly, we can conclude that ABCD is a rectangle. And I'm going to try to fit that in here. And the reason for it being a rectangle is by theorem 6-18. If you want a better way to read this theorem, it's in paragraph form, but you can find it on Pearson, and you can get it. If mine is kind of hard to read, writing with a stylus on an iPad is not the easiest thing to do. But if you want to be able to see it more legibly, you can access it on there. Our next example is going to be some algebra. For what value of x is this parallelogram a rhombus? We know that a rhombus, its diagonals are angle bisectors, which is going to make the measure of angle ABD equal to the measure of angle CBD. So that means that 6x minus 2 is equal to 4x plus 8. Just do our algebra here, subtract the 4x and add the 2, and we get that x is equal to 5. Okay, and our last example is a same thing, finding out what x and y would need to be in order to make this a rhombus. So we know that 3y is going to be equal to y plus 44. We also know that 4x minus 16 is going to be equal to 2x plus 4. It's not necessary to do a system of linear equations here because you have one variable in each equation. So in this one, and for this case, you can subtract the y over and divide by 2, and y is 22. And then over here, the bottom, you can add the 16, subtract the 2x, and then x is equal to 10. Okay, make sure you bring your notes to class, and I will see you guys later. Have a good evening.